Hello again, grade 7s. In today's lesson, we are going to wrap up the lecture-based portion of the unit on heat and temperature by talking about RSI values. However, there's still going to be quite a bit of content to go through to finish the unit up. It's just going to take place more from a self-directed mindset as opposed to the direct teaching that I'm doing in these PowerPoint presentations. So the learning outcome for today is to compare heat transmission in different materials, and we're going to do that by looking at RSI values and calculating them. Okay, so what is an RSI value? An RSI value describes the resistance of a 1 centimeter thick piece of a specific material to the conduction of thermal energy. That's not totally clear on what that means, so let's describe it a bit differently. Materials that are good heat insulators have a high RSI value. Now, just as a quick refresher in terms of what a good insulator is. So if we took like a solid object that's a good insulator, steel, for example, is an example of a good insulator, and looks at the particles that make up steel, even though these particles are close together, particles in a heat insulator don't vibrate very easily. So they do vibrate back and forth, but they have so much trouble vibrating back and forth that you don't really have those vibrating, those collisions between vibrating particles that can effectively transfer heat. Good heat insulators have a high RSI value. And we'll look at an example of this just in a moment. So the higher the RSI value, the better it is at being a heat insulator. Conductors, on the other hand, have a lower RSI value. So conductors would be a material. Then one material that comes to mind for a good conductor is copper. So the particles that make up a heat conductor, they have no problem vibrating. They can vibrate back and forth, they can collide with their neighboring particles, and they can transmit thermal energy. Good heat conductors have a low RSI value. So the RSI value is all about your resistance to conduct thermal energy. So if you have a high resistance to conduct thermal energy, that means that you are a good insulator. If you have a low resistance to conduct thermal energy, you're a better conductor. Okay, let's look at some common materials. Maybe common materials you could find in your house. Okay, so in your house, obviously glass is a common material. Your windows would be made out of it. And if I look at the RSI value for glass, it's 0.017 per centimeter. That's a pretty low RSI value. And again, if something has a low RSI value, it means that it's a good conductor, or I shouldn't say it's a good conductor, but it's a better conductor. Good conductors of thermal energy have low RSI values. So what this means is glass is good at conducting thermal energy, which also leads to the problem with glass. You want to keep thermal energy inside of your house, but since glass is a good heat conductor and has a low RSI value, you tend to lose a lot of thermal energy through your windows. Now, there are certain things we can do to improve this. Like we can make, instead of having like a double pane of glass, we can use a triple pane of glass. We can increase the thickness. Or I think some panes of glass have like an inert gas that's between the different layers, and that inert gas can actually make the RSI value higher, thereby restricting the flow of thermal energy to the outside. The other common material I want to mention is fiberglass. Now, you would only be able to see this if you have an unfinished basement or part of an unfinished basement. And if you do, you probably notice that the walls are surrounded with this pink foam. Now, that pink foam is fiberglass, and don't touch it. If you touch the fiberglass is actually made up of a bunch of like really, really tiny, I almost want to call them like little tiny like threads of glass. And you'll notice that if you touch the fiberglass, you get super itchy. Well, the reason you get itchy is because you're getting scratched by the fiberglass. I know this through personal experience because when I was growing up, we had an unfinished basement, and I thought it'd be really cool to touch the, like really soft looking pink material, not realizing that it was actually fiberglass and they could scratch you. So the itchiness was really, really unpleasant afterwards. Again, don't do it. However, well, why do we put fiberglass in the basement? Because it has a higher RSI value. High RSI value means that it's good at resisting thermal energy transfer. So again, we want to keep as much thermal energy as we can inside of our homes, and thermal energy is always trying to escape. It's trying to go to the area where it's cooler, which is the surrounding environment. So thermal energy from your basement is trying to go out into the ground. By putting the fiberglass as kind of like a barrier between the two, you're restricting how much of that thermal energy can leave. Now, fiberglass isn't the greatest in terms of restricting the flow of thermal energy. I think like a better material to use is you can use a spray foam material, which does have quite a bit of a higher RSI value, but it's way more expensive. So you get into that problem where you're trying to like balance the efficiency of a material and how much it costs, which I think is why most people tend to go with just the regular fiberglass because it's cheaper and it does like a decent enough job. What we're interested in doing is calculating the total RSI value for a material. And we can do that using the following equation. The total RSI value for a material can be calculated by taking the RSI value per centimeter and multiplying by the thickness. So what this equation tells us is there are two things you can do to increase the resistance to thermal energy. So let's say we want to make this bigger. We want to make the total resistance to a thermal energy transfer larger. Well, one thing we could do is we could make the material thicker. And again, that's why people tend to use the triple panes of glass compared to the double, because if you increase the thickness of glass, you can actually increase the total RSI value. The other thing is, if you don't want to increase the thickness, you could choose a material with a better RSI per centimeter. So that might be like choosing blue plastic foam panels in comparison to fiberglass, because the RSI value per centimeter is 0.11 larger for the blue plastic foam panels in comparison to the fiberglass. But anyways, let's work through some calculation problems here. So example 1, I want to calculate the total RSI value for a 3 centimeter thick piece of fiberglass. And again, we're going to show work for this using our 3-step procedure, which is step 1, write the equation. Step 2, do the substitution of numerical values with units. And step 3, get the answer. Okay, so step 1 is let's write that equation down. So my total RSI value is equal to the RSI per centimeter multiplied by the material thickness. Okay, now it wants it for fiberglass. So the RSI value per centimeter for fiberglass, if you refer to this table, is 0.24 per centimeter. So when I sub the numbers in, this would be your total RSI is the RSI per centimeter, which is 0.24 per centimeter for fiberglass, multiplied by the thickness. I want to make the piece 3 centimeters thick. So we're going to go 0.24 per centimeter times centimeters. That's actually going to cancel off the centimeter units. Your final answer is going to have no units at all. And 0.24 times 3 gives you 0.72. So that's why I can calculate the total RSI value. Well, let's look at some other variations. So example 2 says, determine how thick a sheet of glass must be in order to provide an RSI value of 0.085. We need to actually manipulate the equation to get it into a format that we can use. However, because we haven't talked about algebraic manipulations in grade 7 so far, I'm simply going to show you what the variation of the formula looks like. Okay, so what we know in this case is we know the total RSI value, and we also know the RSI value per centimeter, because we know for glass it is 0.017. So how would you calculate the thickness? Well, the thickness can be calculated if you take the total RSI value and divide by the RSI value per centimeter. So the total RSI value that's 0.085. Again, the total value has no units, and the RSI value per centimeter is 0.017. Let's plug these numbers in. So you have the thickness to be 0.085 divided by 0.017 per centimeter. And that's going to give you a material thickness that is 5 centimeters. And let's look at one other variation. So in this one, it says we have an unknown material. So I don't know what the material is. And it tells me what the material thickness is, and it tells me the total RSI value. And what I want to do is calculate the RSI value per centimeter and then identify the material. Okay, so this time around, I know the total RSI and I know the thickness. I want to calculate the RSI per centimeter. If you manipulate the equation to do this, the RSI per centimeter would be the total RSI value divided by the thickness. So this would be equal to the total RSI, which is 0.4, and then divided by the material thickness, 2.5 centimeters. If we calculate this, this would give us an RSI per centimeter of 0.16 per centimeter. Well, what material is that? Look at the chart. The chart has, how do you say this? Vermiculite? Let's go with that. So vermiculite has an RSI per centimeter of 0.16 centimeters. Therefore, the material is vermiculite. Okay, so that's it for this lesson on doing RSI value calculations. And you can practice this by completing the assignment called Insulation and RSI Values. And I believe that's going to take you until the end of the topics 4 through 6 work booklet. And then topics 7 and 8, like I said, we'll deal with it more from a self-directed mindset. And I will talk to you later.